Alright, so we're going to keep having some fun with these formulas for geometric shapes. And this one is really fun in my opinion because we're really just solving things how we want to solve them. So with this, we're supposed to list the shapes you would use to find the area of this shape. So we're given some composite figures. Composite means it's made up of two or more. So we can see clearly in this one, sure, maybe we've got a whole circle here. Maybe it goes all the way around like that. But then we're left with this random object right here. I don't know how to find the area of this. We got to find all of that. What if we just did this? We recognize that this is a circle, but only half of one, and we just drew the line right here. That way we've got this height is radius of r, because this is the center right here. This whole thing would be d, right? And so the area of this piece would be half of the area of a circle, right? Because that's what it is. And so half of the area of a circle would just be pi r squared times 1/2, right? So that's going to be the area of this semicircle up here. Next, I see that I have, I don't know, we could say a rectangle with a triangle, but more accurately, we could just say that this whole thing is a trapezoid, right? We've got base 1, base 2, and then we've got the sides right here. So the trapezoid area, like we found, was base 1 plus base 2, right? Divided by 2, because it's like we're finding the average between them, and then multiplying by h. So here's our area for this whole thing. So to generalize, because we're not given any measurements or anything like that, to generalize the composite area of this figure, is going to be the combination of these two, because this is its own separate shape and this is its own separate shape. But since they're together and they're all one shape, we're going to put them together with addition, right? So we're going to take this 1/2 pi r squared plus b1 plus b2 all over 2 times h. And since we have the area of the semicircle plus the area of the trapezoid, and that's what this shape consists of, this is going to represent the area of this entire composite figure. So that's what finding the composite area is. So just like last section, it's taking things we know and just putting them together with some intuition. We knew that we couldn't use the entire area of a circle, so we just used half of it. So we multiplied by 1/2. So things like that will be coming up, and it's going to be up to y'all to get creative and use some critical thinking to figure out how to solve these problems. So on to the next one. It's a little low down here, but we're just going to roll with it. So the first thing I see when I look at this one is that it tells us that this line is parallel to this line, right? And immediately, when I see parallel lines in a shape, I'm thinking parallelogram, right? So a parallelogram is a shape with two sets of parallel lines. And so this is kind of weird because we're drawing under the assumption that it works perfectly, but that's just what we can do here. So we'll try and make a line parallel to this one too. To do that, I'm going to start at this corner. I'm going to draw a line down to that corner. Got a little curve in it, but that's okay. And so we're going to say that this line is parallel to this line. So now we have a perfect parallelogram. Do we know how to find the area of a parallelogram? Yes, we do, right? Very clearly, on the previous pages, we have it that the area of a parallelogram is just base times height, because we can take this triangle and we can have it fill in this spot right here. So it's just going to be base times height. I'll draw an arrow there. Base times height. And then for this triangle, what do we know about triangles? Well, we know that they're half of rectangles, and we know what the rectangle formula is. So we know that the area of this triangle here, if this is H and this is B, we're going to have 1/2 HB, right? Or BH, 1/2 BH. So to generalize this, we're going to use different variables for B and H just because it seems confusing if we have 1/2 BH plus BH, because then we really have 3/2 BH, right? And I can't say that that's necessarily going to be the formula for shapes like these. So what we're going to do is we're going to call this H2 and B2 for the triangle, and for the parallelogram it'll be B1 and H1. So the composite area of this figure is going to be a combination of these two, right? So we're going to have A equals B1H1 plus 1/2 B2H2. And I did, once again, just did the B1H1, B2B, or H2 because we have different measurements, and I can't say that those are always going to be the same, so we're just going to notify, or we're just going to write those in this notation. So as you can see, though, the composite area is just putting together the areas of figures we already know. We already know how to find the area of a parallelogram. We already know how to find the area of a triangle. We already know how to find the area of a trapezoid and a circle or a semicircle. So this is all about just putting together the pieces that we know to generalize for bigger and more obscure shapes.